First of all, I'm going to talk about the work we're doing around productivity, and then John's going to follow on and talk about work we're doing around climate adaptation. So, why are we talking about PAS's publicly available specifications in terms of the standards landscape? Quite straightforward. The Institution of Civil Engineers has been around for a long time. It's been around for over 200 years. It is here as a charity to ensure that the world has the engineering capacity and systems that we need to enable both the people and the planet to thrive. That's what we're here to do. We do that by harnessing the knowledge of our members and their professional networks to make sure we widely share that knowledge. And really, as the core kind of part of that is taking that knowledge and turning it into commonly applied ways of working, i.e. standards. We all know as civil engineers and infrastructure professionals, we like to work to a rule book, and that is what the PASs provide for us, that kind of common rule book around which we can provide tools in terms of how to use the rule book and then hopefully develop our skills in using those tools. And we are building, in these two standards around productivity and climate adaptation, we are building on the success of the PAS, which has been touched on already, that we launched a couple of years ago, which is 2080, the Carbon Management Standard. So just to reflect quickly back on PAS 2080 as to why we think this is the way to go forward, I think that today is a really timely event because yesterday, back down in London, the Construction Leadership Council had its kind of 1-year anniversary of its 5 client carbon commitments, which was touched on in that previous session, which is a massive amount of progress, really, when we think about where we have come from. PAS 2080 is a carbon standard, was relaunched, say, in 2023. And here we are now just 2 years on and adding to already signed up clients, including National Highways, who we had here, Anglia Water, Heathrow, Sellafield, Northumbrian Water, who set this thing up. We have now added in 3 new clients, Environment Agency, Transport for London and Scottish Water. Across the lot of them, the headline figure was they are collectively in charge of £30 billion worth of infrastructure projects. So there's a lot of infrastructure projects which are now going to be delivered using the client carbon commitments. And there are 5 of them. They are very simple. They are very measurable, which is key. And as you can see there, number 5 is adopting the Carbon Management Standard PAS 2080 as a common standard for assessing, benchmarking, and then reducing the carbon impact of projects. And it's that exact kind of same methodology that we are seeking to emulate in productivity. And why are we interested in productivity? Well, everybody's seen this slide about 20 times, probably more, I'm sure, which is the ONS's study of a couple of years ago now, which really just kind of looks at how productivity improvement in our sector has just completely flatlined versus has improved in across the sort of UK markets overall. It's important though that this measures output per hour. It's very much a measure of stuff done per hour. They have another couple graphs which are often also used. One on the left, again, to really kind of highlights how within our sector, there are different sectors which are perhaps slightly better at improving productivity, which sometimes don't get as well mentioned. And interestingly, the one on the right, which very rarely gets mentioned, is that in civil engineering, productivity is actually better than the whole of the UK industrial sector as a whole. We don't very often see that graph. So let's not get too down on ourselves, actually. We are not completely useless as a sector, but clearly there is improvement required. And as I say, the ONS is all about measuring, number of holes dug per hour, that kind of measure. There is way more to it than that, and we know that. And one of the things that we know is a real cause of productivity, holding back productivity in our sector, is the amount of errors we make in performing the construction activities we do. And again, this comes right back to what we've just been talking about on the panel here, and the importance of pre-planning. And when the Get It Right initiative, which is an initiative the ICE supports, did research a few years ago, some very clear headline figures that when we look at the cost of error in our industry, it can equate to anything up to 25% of the project cost. It's a huge cost, costing our sector up to £25 billion a year. I mean, we could build a lot of infrastructure with £25 billion a year. And when you actually look at the cause of error in construction, the usual kind of stories get put out. Every project's different, site conditions are poor, are doing it in the wet, in the cold, in the rain. Well, actually, that really isn't the cause of error. When you look at the little spider chart there on the right, the cause of the error is inadequate planning. It's late design changes. It's poorly communicated design information. These are the causes of error in our sector. So when we start looking at productivity, what we're clearly trying to avoid is another one of these. Pertinent to where we are today, we don't want another high-speed 2 to be cancelled, so we know this is important. But we also appreciate that there is way more to this than just measuring how many holes we can dig an hour. This is not what we're trying to achieve with our paths for productivity. We understand that a big part of this is about added value. So when we are now embarking on our standard for productivity improvement, we are doing so building on our 2022 State of the Nation report, which really kind of looked at a much more holistic level about what do we mean by improving productivity in infrastructure. And what do we mean? I mean, the key thing is about both, yes, being more efficient by digging more holes more quickly, but it is about being effective. It is about digging the right holes in the right place, and recognising that we just need to use our resources far more wisely. So our key lessons from our State of the Nation report were really, and the top one is the key one, but people, culture and mindset are way more important, or just as important as process change, new technologies, all important, but it really is a cultural piece that we're trying to drive here. But we really recognise that the sector is already pretty innovative, pretty productive in certain places, and if everybody just operated at established best practice level, we would be way more effective, way more productive of a sector. So,
attention, please.
ooh.
Mr. Sands, please go to
Oh.
reception. Attention, please. Mr. Sands, please go to reception.
Well, the transport professionals in the room all know what that means. So, so anyway, we'll carry on. And the third point there, as I already touched on, the greatest productivity improvements happen before construction even begins. So we packaged that all up. Alongside State of the Nation, we produced a ready reference guide in terms of whole life productivity improvement. That exists. That's live on the website. We'll be updating that this year as a keen piece of work that will sit and work alongside our PAS. But this is what our PAS will really include. It really brings all those things together. It's about the whole life cycle infrastructure project, and it will focus on effectiveness and efficiency and making sure that we are bringing broader benefits with us. It will be relevant to the entire supply chain, just as the 2080 standard is. So it will be forward-looking. We're not looking back at the past, it will be forward-looking, and it is fundamentally, as I say, about improving productivity throughout the whole process, not just the construction phase. So where are we at with it? We are working with our key partner. We're delighted that the Department for Transport is putting in the funding to deliver this standard, which is great because it will be, it'll be sort of driven out across the entire transport sector as a bare minimum. But we, as ICE, are leading in terms of being the client liaison on this to make sure that all the other infrastructure sectors are also engaged in this. This isn't just seen as a DFT piece of work. This is a piece of work to be used by the entire infrastructure sector. And we're currently at the stage of forming a steering group which does bring in all the key stakeholders and all the infrastructure sectors to make sure that we do make sure something is applicable across all sectors. So that is the current process. We will be delivering it throughout the course of this year, launching it probably about this time next year. Alongside it, we will be producing, just as we did with the carbon standard, we'll be producing a guidance note which makes it more easily applicable. And really the action, the watch next steps really here is to produce both the standard and the guidance note, we will need case studies, we will need examples of best practice. That's what we've got in the 2080 standard and its associated guidance note. So really, the ask is, and come and see us on the stand later, if you have great examples, you have specific things that you're doing in the productivity space, please come and tell us, because we will be looking for your input. And with that, I will probably take questions at the end collectively, I imagine. So I will hand to John to talk about a similar bit of work that we are doing in adaptation. Thank you.
Thank you.
Thank you, Mike. I like simple controls. It's got next and back on it. So I've come to talk about the Adaptation Pathways, PAS, which we kicked off this week, and a lot of what Mike said is relevant to what we're doing as well. Case studies, we're looking for case studies, and I'll touch on those at the end of the presentation. But I thought I'd talk a little bit about the history behind the PAS. It's something, adaptation pathways is a concept that's sort of evolved over the past 15 years, and a couple of colleagues, people I work with quite a lot, Tim Reeder, one of my work colleagues, and Peter Van Lanny, kind of came up with the concept, and looking at the Thames Estuary 2100 program, the adaptation pathways concept was used in that. And Peter's used it in a variety of infrastructure resilience, shoreline management, and other kind of projects as well as a concept. And in 2021, BSI published a full British standard on adaptation pathways, using adaptation pathways for decision-making guide, with Tim and Peter being the two sort of lead authors in that. But one of the things working in the infrastructure sector, and I chair the UK's Infrastructure Operators Adaptation Forum. Some of my colleagues here, including Alison Walker from HS2, and primarily Alison, was thinking that the BS is too high level and we need something for infrastructure more detailed. So this idea of having a PAS for infrastructure came out. The idea to have focused words in that for infrastructure professionals and bringing in case studies to show how to apply it. And that's another ask. You know, if people have good case studies on using pathways for infrastructure, to come and talk to us. A couple of the slide pictures there. There's a 9 steps in BS 8631 on the top right. There's a pathway that was used for the Thames Estuary 2100 project, and a picture of the Thames Barrier. I always have to have a picture of Thames Barrier on PAS presentations on adaptation pathways. But they're a great tool. Pathways is a great tool for dealing with uncertainty. And if any of you have been involved in looking at climate projections and looking at infrastructure design life, infrastructure actual life, that sort of thing, you realize that climate projections are quite uncertain. We don't quite know what the scenario to use for the end of the century. We're talking in some areas of 4 degrees above pre-industrial levels as a global surface temperature increase, and an average as well. And there are extremes around that too. 4 degrees is really frightening. I won't go into that, but there are really some fundamental issues that will crop up regarding survival on the planet with 4 degrees. So we need to do something about that. But the uncertainty in the projections means it's difficult to design for maybe a 120-year design life for a bridge, or hundreds of years for a nuclear power station. And adaptation pathways give you a concept to deal with that sort of design philosophy. Dr. Hashmi at Birmingham wrote a report for the UN. There's a link on the slides which you can click, on adaptation pathways in transport. And she came up with some good guidelines there with a 5-step process rather than 9 steps, which is quite useful. She was saying that using the pathways can involve a mix of approaches and things like the scale and complexities and the objectives of the client. And you might have to refine when you're looking at pathways. But one of the great things I find about pathways is you look at the sort of pre-planning, early conceptual stage, what you're going to do with the infrastructure, be it a huge system like the Thames Tidal Defences or a component, like a bridge expansion joint. You look at what that component or system is going to need over the next sort of 100 years, or even take time out of it and look at sea level rise, 500 millimeters, 1,000 millimeters, or temperature, 2 degrees, 4 degrees, or wind speeds. Look at thresholds around where you need to intervene. And one of the classic things with an adaptation pathways approach is you look at options over time and work out when you will intervene. and make sure that when that intervention takes place, it doesn't compromise the next intervention, so it doesn't lock in what could be maladaptation. So these are principles we'll build into the paths to help people use the concept. Yeah, make sure interventions don't compromise future interventions. This is one example of long-term planning. Now, this is from 2011 for the Adaptation Subcommittee. And you look at this pathway here, it hasn't got a time bound on it. It's got deficit in megalitres per day. And the pathway started off, all the pathways started off with leakage reduction and targeted compulsory metering. And then the options kicked in. Do we build a new reservoir at Abingdon? Then after that, Thames 7 water transfer. Or do we build a small reservoir at Abingdon and then go for the water transfer and then reuse water at Deepham's? Or do we start off with the Thames 7 water transfer, then build the reservoir? So this is just an example from, when was it, 2011. And now I live in Oxfordshire, and I know the Abingdon Reservoir concept is taking root, and we're looking at planning applications, going through the planning process for Abingdon Reservoir. So this is a simple example of 3 different long-term pathways for dealing with deficit in water supply, using the pathways approach. Thinking about subsystem and component level, with coastal defences, sea level rises by the end of the century. You'll see estimates, 500 mil or a metre, we don't really know. Depends on tipping points and what's happening with the climate. And the climate seems to be changing much more rapidly than we thought 10 years ago, maybe even 5 years ago. And scientists that I work with are quite concerned as to tipping points with things like the permafrost melting in Siberia and methanes, which are very potent greenhouse gases being released into the atmosphere. But because of all that, there's still this uncertainty as to how sea levels might rise. But if you're building a sea defence, the simple pathway approach really is to build the foundations big enough, strong enough to cater for successive raising of that sea wall. Quite a simple concept, really. And then maybe readdress the issue in 30, 50 years' time and keep on doing that. And these approaches to build something now that is adapted in the future are compliant with existing standards, because they're building something that's more resilient than is required in existing standards. And bridge thermal movement, another example. If you've got an expansion joint, we replace those expansion joints fairly frequently compared with the overall life of the structure. So if we have an expansion joint that might be 200 millimeters wide in a slot that's 250 wide now, well, maybe make that slot 300 or 350 wide, so as in future, when we know more about the thermal range, we can put a larger expansion joint in place. So it's just simple things like that as adaptation pathway concepts, but more complex issues when you get big complex systems as well, of course. Thinking about the context and standards, I've worked a lot on standards, and well, for the past 20 years. I was Network Rail's civil engineering team standards manager 20 odd years ago, and in the past 10 years I've got heavily into ISO and European standards. ISO 14090, Adaptation to Climate Change, sets a framework for adaptation. It's been around for 5 years, and adaptation pathways support the implementation of adaptation by looking at these sorts of options over the longer term. The next generation structural Eurocodes, I've worked quite closely conversing with Steve Denton from the UK, who's the current chair of SEN Technical Committee 250, which looks after the structural Eurocodes. 3 of those next year are going to come out requiring climate change to be taken into account for wind, snow, and thermal loading. And adaptation pathways can support those approaches as well. That will have a significant influence on things like design philosophy and mindset. I think, Mike, you mentioned mindset earlier. Mindset's got a lot to do with this. We can build things that are better than the standards require. And there's a SEN technical report coming out in the autumn, which I'm leading the drafting of. We kicked that one off this week, like we kicked off the PAS this week, and that will advise designers, operators, maintainers as to where to source climate data for infrastructure standards, including the structural Eurocodes. There's a lot of work going on in SEN to modify not just the structural Eurocodes, but many infrastructure-related standards for the future climate. Until that happens, we need some guidance to adapt the way we design things, and the pathways approach, the PAS will help with all that. So we've actually got a number this week, PAS 3090, 2080, 3090, they kind of roll off the tongue. I'm quite chuffed about it being 2090 because ISO 1490 is the adaptation ISO, which we put together sort of between 2017 and 2019. So we started work this week on the PAS with another consortium sponsored and led by the ICE with lots of partner organizations in there. We've got the funding for the PAS itself. We're still looking for funding for the guidance note that will come out concurrent with the PAS when it's published, probably the middle of next year. Its scope covers usage by planners, engineers, designers. You can read all that there. It can be used at any scale. I mentioned expansion joints, and I mentioned complex systems like the Thames Estuary, Thames tidal defences. It can be used at any scale. And it'll have some guidance on choosing adaptation measures, including nature-based, nature-first solutions, those sorts of solutions as well, which you need to think about in terms of sustainability. Specifications will give requirements for developing and applying pathways with guidance on choosing appropriate climate change scenarios. And I saw one of my friends sent me a note from one of the railway magazine publications this week that RSSB, the rail industry, have settled on climate scenarios for the whole of the rail industry to work to, which is great. So Alstom, the rolling stock manufacturer, will use the same climate scenario over their rolling stock as Network Rail will be using on the structures, Transport for Wales, Transport for Scotland, etc., etc. So climate change scenarios, choice of them is quite important for consistency. And there'll be guidance on overcoming, like I said, these design life constraints that we have in design codes. I call them constraints because people feel constrained by them, but having worked on Brunel structures and realizing this year's the 200th anniversary of passenger railways in the world, yeah, there's lots of old stuff out there on railways that nobody thought about design life when they built them, but we keep them going. And pathways have been part of that without us really realizing it. We'll have a methodology for looking at the co-benefits of adaptation activity alongside net zero and sustainability considerations. So it kind of aligns with PAS 2080 and think about construction, net zero and co-benefits. And there'll be some words about governance, which is really important. Who's the champion that leads the adaptation effort in an organization? Some organizations don't like the word champion, but who is that leader that takes this issue, grasps it, and sets up the systems to make it all work? ISO 14090, Section 8, talks about implementation. It gives their guidance to people who lead and govern organizations that they have to actually almost get their hands dirty getting this topic going. Pathways really helps with that. Metrics, key data, and how you work out adaptation pathways. The case studies, like I mentioned earlier, and I'll keep saying it, are going to come in a guide towards the end of it, but we need people to come and volunteer case studies. So if you have any case studies on using adaptation pathways in infrastructure, that would be great. And I always say it supports one of my favorite other standards. I'm a bit of a standards nerd, actually. As a standards nerd, I like ISO 55000 asset management. It supports 2080 and 14090 and BS 8631, which is the existing adaptation pathways, overarching British standards. Now, the next step, as we've said, IC are the sponsors with funding partners from across the sector. So we're actually going through, a bit like Mark was saying with the productivity PAS, putting together the steering group, and we're making sure we've got a balance between consultancies and construction professionals and infrastructure owners and so on at the moment. That steering group has all these representations on it. We've got a much wider technical advisory panel who are going to help us getting the text right. They'll be consulted as we go through these stages here. There's draft 1, draft 2, draft 3 stages. There's a public consultation. Watch out for that if you're really interested. So that's going to happen probably in about a year's time, I would think, the way these things take to develop. And as I said earlier, there's going to be a guidance note with real-life case studies. We've got a handful of case studies, but the more, the merrier. And I'm really pleased to say that I'm the technical lead author for all this work. It's a real great opportunity to be involved in that because I think it's an opportunity to change mindsets, philosophy, and get us building and maintaining climate-resilient infrastructure. And I think that's it. Thank you.
Thank you very much. Thank you very much, John. Now, I'm conscious of time, and because of that, except there's a very pressing question from the audience, I would say there are questions if you meet Mark and John just after their presentation, after we finish, and they can answer those questions for you. But I have a question for you, Mark, because all this sits very nicely within engineering knowledge in the ICE, which you're director of, and sits under the Learning Society portfolio, which I chair as well. We may have all these fantastic things, PAS, coming out, but without communicating them to the industry properly, they're nothing. So what strategy do you have in place to ensure that, first of all, they're well communicated and adopted as well?
A super question, Alice. So the good news. I mean, today really marks the start of talking about these two new standards, and a press release is in the throes of being finalised and will be being issued, if not today, then in the next day or two, because we really do need to make sure everybody is aware that we are working on these things so that people can get involved, if not on the steering group, but certainly on the much broader review panel, which each of these PASs will be setting up for. And there's an opportunity for lots of people to get involved in the review panels, so it is an opportunity to come forward and say, yeah, I'd like to be involved directly in it. That's great. As John just said, both of these, all these standards work through consensus, and so there will be a public consultation on both of them. Probably sort of later this year, early next year, probably, and depending on how development goes. And again, we'll be kind of very strongly advertising that to make sure, again, that as many people get engaged in the consultation as possible. When we did the carbon one, I think BSI were a bit overwhelmed by the volume of response to consultation, which added about 6 months to the development phase. But it's really, I mean, the proof is in the pudding. It's really important to take that time to get that level of engagement, because now the clients are all adopting it. So it's really important at that stage. So I think, we will be communicating widely what we're up to. Initially, as I say, this week, telling everybody what we're up to, but then when we get to these key stages where we're seeking to form review panels and go out to public consultation.